two that we're going to look at, perfect square trinomials and difference of squares. Difference of squares is easier to identify than the perfect square trinomial. So a perfect square trinomial has perfect squares for its first and third terms. That means the first term in the trinomial is a perfect square like 4, and then the last term is also a perfect square. And then something important about the middle is twice their product. And if you have that situation, then you can shortcut the factoring of this by just taking the square root of the first term and the square root of the last term and keeping the same sign. So let's take a look at some examples. We are going to factor them, and we're also going to solve them using our zero product property, which we did back on day 2 of our unit. So looking at my first term, it is a perfect square because it's 1. 1 times 1 is 1. And my last term is a perfect square because 2 times 2 is 4. And my middle is twice their product because 2 times 1 is 2 times 2 is 4. So to simplify this, or to factor this, I would just do x, taking the square root of that first term, which would be x or 1x. Our sign's a plus, so it's going to be a plus. And what is the square root of 4? It is 2. So there's my factoring. That's factoring. But then it also says to solve it. So remember, solving is when we use that zero product property. X plus 2 equals 0. X plus 2 equals 0 because we're setting each factor equal to 0. And then we solve them. So we get x equals a negative 2 and x equals a negative 2. Since that's the same number, we only need to write it once. Our solution is negative 2. So that's the solving part. All right, the second example, perfect square. Perfect square. The middle is twice their product. So I can factor this with a shortcut, x and x. Middle sign's a plus, so both pluses. What is the square root of 49? It is 7. So there we are factored. I'm just going to put F for that. And then solving it is where you set them equal to 0 and solve. Because they're exactly the same, and I can see that just by looking at them, I only need to do the 1 because I've already shown in example 1 that I'm going to get the exact same answer. So x equals a negative 7. And that would be my solution. All right, number 2. Perfect square. Perfect square. My middle is 2 times their product. So I can take the shortcut in factoring, y and a y. My middle sign's a minus, which means both of these have to be minus because the sign is the same as the middle for perfect square trinomials, and then the square root of 1 is 1. So that's my factoring. And then solving, I'm just going to set one of them equal to 0 and solve because they're exactly the same. So y is equal to 1. That's my solution. Number 2, or the fourth example. What's that? Number 2. D. Perfect square, and this is twice their products because 1 times 9 times 2 would be 18. It is a negative. So m, both going to be negative, and what's the square root of 81? 9. So that's my factoring. And then solving it, set one of them equal to 0 and solve. So what is my solution? My solution is m is equal to 9. E. Now, those first 4 examples, you could just do them the way we've already learned how to factor, finding factors of 81 that add to give you 18. I mean, you could just do that. E is where it gets a little complicated. Who wants to take 49 times 25 and then find factors of that huge number that add to give you 70? So that's why the shortcut is helpful. Because if I notice that that's a perfect square, square root of that is 7, and that's a perfect square, square root of that is 5. 7 times 5 is 35, times 2 is 70, so this is a perfect square trinomial, which means I can shortcut it. Square root of that first term is 7x. I have a plus sign, so these will both be pluses. Square root of that last term is 5. And there's my factoring. Now the solving for this one can get a little bit more complicated because I have to do a two-step. So this might be a problem where you do have to show your work where maybe on the ones above you don't. So 7x is equal to negative 5 divided by 7. X is equal to negative 5/7. F is also one that I would not want to do using slip and slide because that would just be a big number, 16 times 25. So I notice that's a perfect square. That's a perfect square. Square root of that's 4. Square root of that's 5. 4 times 5 is 20. Times 2 is 40. So it is a perfect square trinomial. Square root of 16a squared is 4a. It's a minus in the middle, so these are both going to be minuses. And the square root of 25 is 5. And that's my factoring. So if you're asked to factor, that's it. You're done. But if it says solve, you've got to do that next step where you use that zero product property. Don't have to do it twice on this because even though we have two factors, they're exactly the same. And then I get my solution of 5/4. Every year someone usually asks me, do I need to write it that way, the factors? No, you could write the factors as 4a minus 5 quantity squared. You could do that too. In fact, that's what the rule above says to do. I just like to write them both out because we're in the habit of doing that. Then we get to G. And you look at G and say, well, this isn't a perfect square. Neither is this. But hopefully you remember that one of the first things you should always do is look for a GCF. This does have a GCF of 2. So I'm going to factor out a 2 first. That's one of my factors, a 2. X squared plus 6x plus 9. Now this is a perfect square trinomial. Perfect square for my first term, perfect square for my second, and this is twice their product. So I'm going to factor that. I'm going to leave that too because he is part of the factoring. Square root of x squared is x. It's a plus, so these are both pluses. Square root of 9 is 3. So that's my factoring, and you have to include the 2. It is a factor. And then for solving it, I don't need to set 2 equal to 0 because it doesn't have a variable, so it's not something I can solve. But I'm going to set the other factor equal to 0 because they're the same. I don't have to do it twice. And I get x is equal to a negative 3. And that's my solve portion. Now I get to H. H. Perfect square, and this is twice their product. So what is the square root of x squared? It's x. We have a plus sign, so we're going to have a plus sign and a plus sign because that was plus in the middle. Square root of 16y squared is 4y. Now this one I can only factor. I can't solve it because it's not one variable. And if I solve it, I would just be solving it and saying x equals negative 4y, or the opposite, solving it for y. So that one is done. That's why the directions said solve if possible. If we have two variables, we're not solving. So that is perfect square trinomials. It's not something necessarily you have to remember because you could do it with one of the other methods we've learned, but it does make problems easier, especially problems like this one and this one, because those would be some big numbers to think of factors for. All right, let's go to the back. have to recognize. The difference of squares expression is a binomial. Remember, that means it has two terms. And both terms are perfect squares. With a minus sign in the middle. That's why it's called a difference of squares. Remember, I told you mathematicians aren't real creative. They call it what it is. If I have two perfect squares and there's a minus in the middle, it's a difference of squares. So similar to the front, you find the square root of the first term and the square root of the last term, but instead of the signs both being plus or both being minus, now they're going to be opposite. One's going to be minus and one's going to be plus, which actually means we're going to have two solutions. So looking at the first example, A, perfect square, and it's a difference, so it is a difference of squares. I know one will be a plus, one will be a minus, that's the rule. X squared, square root of that is x. 9, square root of that is 3. So that's my factoring. And then solving it, I set each one equal to 0 and solve. Which what you're going to notice here is that you'll get the same number but different signs. So our solution is negative 3, positive 3. Example 2. Perfect square, difference. So it's a difference of squares. Square root of x squared is x, plus and a minus. Square root of 25 is 5. So that's my factoring. And then solving, set each equal to 0, and solve. And I get negative 5 and positive 5 for my solution. Then we get to that third example and say, well, those aren't perfect squares. But you should be looking for a GCF. It didn't really need to do with the first examples because the first term was a 1, so there's not going to be a GCF with that. But with this example, there is a GCF, so I have to think what goes in to both 8 and 18, and that's going to be a 2, so I'm going to factor out a 2. And 4a squared minus 9. So now I do have a perfect square, and a difference. So I can factor that. This is my factoring part. By taking the square root of 4a squared, that's 2a. One will be a plus and one will be a minus, and the square root of 9 is 3. There's my factoring. Solving this one, 2a plus 3 equals 0, and 2a minus 3 equals 0. So I have to solve it, minus 3, and divide by 2, and then solve this one by adding 3, and dividing by 2, and I get negative 3 halves and positive 3 halves. Oops. Now I get to D. Perfect square, but it's a sum. Nothing I can do, can't factor. All right, E is one of those that we have to be careful about because a lot of students will look at this and say perfect square, difference. But there actually is a GCF. And while you would get the solutions correct, you would miss out one of the factors if you don't notice that there's a GCF. It does have a GCF of 4. So we need to factor out a 4 first. 6m squared minus 25. Then we still have a difference of squares. I'm sorry, that's a 9. 9m squared minus 25. So we have a difference of squares. That's a perfect square, and that is a difference. If I didn't factor out the GCF, I would miss that 4 being a factor. That's what we're doing right now, factoring. So I have a 4 out front. It's going to be a difference of squares, so a plus and a minus. Square root of 9m squared is 3m. Square root of 25 is 5. So that's my factoring. And then solving. 3m plus 5 equals 0. 3m minus 5 equals 0. Minus 5. Divided by 3. M equals negative 5/3. Plus 5. Divided by 3. M equals 5/3. So I have my two answers, negative 5/3 and positive 5/3. Next example, difference of squares. I have perfect square, and a difference. This one's a little bit different than the other ones that we did because the variable's not first, but it's still a difference of squares. Square root of 1 is 1. Plus and a minus, square root of 49x squared is 7x. So that's my factoring. Solving, be careful. If you're one of those that shortcuts your solving by just looking at it, make sure you're careful with this one. Oh, I guess I didn't need the parentheses there. So you're going to minus 1. 7x is equal to a negative 1. Then divide by 7. X is equal to 1/7. And maybe some of you have caught on by now that you're just going to have the same answer, one positive and one negative. So you just solve one of them and then just do the opposite sign of the other. Now when we look at G, not a perfect square, but they do have a GCF. So don't just say, oh, you can't factor it. That's not true. This one does have a difference, and it has a GCF of 3. So we factor out of 3. It's 25x minus 4 equals 0. Now it's a difference of squares, perfect square difference. So 3 times 1's a plus and 1's a minus, 5x and 5x, 2 and 2. So that's my factoring. And then to solve, I'm just going to take one of them and set it equal to 0 because I've already established that pattern with the difference of squares that my solutions are going to be just opposite signs, but same number. So negative 2/5. So my answer here is negative 2/5 and 2/5. And then the last one, which I'm going to have to erase a little bit. Have some space. So I just always make sure, especially with big numbers, that I don't have a GCF. 16 and 81 do not have something in common. What goes into 16? 2, 4, 8, 16. None of those go into 81. So perfect square. Difference of squares, so a plus and a minus. What is the square root of 16y to the 4th? Well, that's 4y squared. 4y squared. And then the square root of 81 is 9. Something interesting here. This is a difference of squares. So I can keep factoring. So one of my factors is 4y squared plus 9. Can't factor that because there's no, it's not a difference, it's a plus 9. This second one, I can continue to factor. Factor of 4y squared is 2y plus and minus, sorry, that was the square root of 4y squared is 2y. And the square root of 9 is 3. And this one we're not going to solve. We could solve these two, but this one, we haven't really learned about that, and actually it wouldn't be something we would do in Algebra